Hey guys, this is Carrie, and this is the answer key video to homework 7, unit 12. So for the first one, a set of test scores is distributed normally. That means a bell curve with a mean of 70 and a standard deviation of 6. So whenever I see these problems, my instinct is to sketch a picture of our normal distribution. So we've got our bell curve, perfectly symmetrical, right? Well, not really, but that's the best I can do. The mean score is 70. That's x bar, using the symbols that we've been talking about in class. And since the standard deviation is 6, if we go 6 this way, we'll be at our first tick mark, which is 1 sigma. And then another 6 will bring us to 2 sigma, 3 sigma, back 1 sigma, back 2 sigma, back 3 sigma. And although I only labeled the first one with a 6, because this is the standard deviation, all of these are 6. And that's coming from this, just to color code it. All right, next up, between which two test scores could 68% of the scores lie? 68% means between -1 sigma and 1 sigma. So looking at the graph, that looks like it's going to be, oh, we didn't actually calculate these. So calculating them, if we go down 6, that'll be 64. Down 6 more from 64 would be 58, 52. Up 6 from 70 is 76, 82, 88. So for 68% of the data will be between -1 and 1 sigma right here. So that will be from 64 to 76. For 95%, I'll use some alternative shading here. Let me just use a highlighter. That's going to be between -2 sigma and 2 sigma for 95%. So that is from 58 to 82. I'm just going to box these so that it's clear for the answers. And then this is a really interesting question. What percent of the test scores lie between 64 and 82? So I'm going to erase out the shading that we had here. And then we'll indicate the region of interest using our pen. So from 64 to 82. So there are many ways that you could solve this one. So one way to think about it would be, well, if we had from -2 sigma to 2 sigma, that would be 95%. But we don't have all of that. We're missing this piece right here. So let's see. Oh, here's a nice way to think about it. Well, we know from -1 sigma to 1 sigma, this is 68%, which means that half of that would be 34%. So this part right here, this is 34%. Now we have the part from the mean all the way to 2 sigma, and that's going to be half of the 95% that we saw up here. So this is going to be 47.5%. And not just the line, the 47.5%, let me color code that something different with the blue. That's going to be half of the 95% that we saw. So if you take the blue part, 47.5%, and you add it to this red part, 34%, that will give you the whole shaded region, which combined gives us 81.5%. So that last one was definitely a little bit tougher because you had to really kind of problem solve some of the missing pieces and addition. Oh wow, my power's almost died, so let me speed through the rest of this. So we've got f of x is equal to -6x plus 12. Find f inverse of x. So if you remember how to solve these, we've got y equals -6x plus 12. And actually, I'm going to walk over to the charger and charge while I do this, so that I don't run out of batteries. This might take me a second. And I don't have any editing ability, so I'm not editing. Okay, I'm in a different room now. So we got y equals -6x plus 12. The inverse function is where we switch the inputs and outputs. So we're going to be doing that in 1 second, just after I plug in. Here we go. There we go. Sweet, charging. Switch input and output. And when we do that, our inverse function will be this new purple function, x equals negative 6y plus 12. So when we switch, the input and output is x and y that switch. Now solving for y, we just use basic algebra. So minus 12 minus 12. That gives us x minus 12 equals negative 6y. We divide by negative 6 on both sides. That gives us negative 1 over 6x plus 2 when we divide each of these by the negative 6 equals y. Finally, we want to revert back to f inverse of x notation, and that gives us negative 1 over 6x plus 2. Now, I meant to do this. The unit this is from is Unit 1 functions. So if you wanted more details about that, you can definitely check your notes. In specific, it was about inverse functions. Next up, this review problem is about average rate of change, which we talked about relatively recently. Average rate of change is another word for slope. So we're going to be computing the slope of each of these functions on this interval. And it says negative 2.4. It should say negative 2 comma 4. Sorry about that. So from negative 2 to 4. So the formula for slope is m equals y2 minus y1 over x2 minus x1. M is equal to 80 minus 1.25 all over 4 minus negative 2. M is equal to 78.75 over 6. Let's see if I have a calculator nearby. I always have Desmos, I guess. 78.75 divided by 6, 13.125. Now, for the second function, we actually need to find our x and y values. Wow, that's strange. Usually it's pretty neat. Let me redo that. We need to find our x and y values. So it looks like when x is negative 2 and when x is 4 are the 2 points we care about. So we should substitute in our points. G of negative 2 is equal to 4 times negative 2 cubed minus 5 times negative 2 squared plus 3. G of negative 2 is equal to negative 4 times negative 8 is 32 minus 20 plus 3. Hopefully I'm doing this math right, but I'm sure you guys will catch me if I'm not. This is negative 49. Next up we do G of 4. And that's 4 times 4 cubed minus 5 times 4 squared plus 3. So G of 4 is equal to 256 minus 5 times 16 is 80 plus 3. So G of 4 is equal to 259 minus 80 is 179. Now finally, you would use the slope formula to find the slope between these 2 points. So M is, let me not use the same color. Let me go back to purple. M is equal to y2 minus y1 divided by x2 minus x1. So M is equal to 179 plus 49 is 8, 1, 2, 1 here, and then 2, 228 divided by 6. Let's do the math over here. 38. And so the question was, which of them had a greater average rate of change? So you would probably answer it in words here, but f of x from the table had a lower rate of change because it was only 13.25. So g of x has the greater rate of change. But you should write that in a full sentence. All right, next up, completely factor each of the following. Oh, sorry, this is also from Unit 1. And the topic was average rate of change. Next up, for problem number 4, completely factor each of the following. Factoring was Unit 3. And this is going to cover a lot of Unit 3, the next few problems. So for this one, it is sum and product factoring. So we get A plus and A plus, which would be nice for our report cards, but also nice for this problem. So we're looking for two numbers that add to 9 and multiply to 14. That is 7 and 2. Now, a lot of students are tempted to solve this and find out what A equals, but that can't be done because there is no equal sign in the original problem. For this one, this is a difference of squares. So that's going to be two things that are, what's the word that we used in class? Wow, I'm blanking on it right now. Conjugates. So one will be minus, one will be plus. And it'll be b times b to give us b squared, and then negative 4 times 4 to give us the negative 16. The middle terms would cancel out because it's a mix of positive and negative, and that looks good. This one is going to be a GCF. So this one, we factor out the greatest common factor. So they both share 4 in common, and they both share x to the 9th. So after factoring this out, 4 times 5 would give us 20, x to the 9th times x to the 3rd would give us x to the 12th, and then 4 times 2 would give us 8, and x to the 9th times, we don't need any additional x's to make this x to the 9th. For this one, it looks a lot like a sum and product problem, but what's strange is you have x to the 6th and x cubed. However, if you think about it like a sum and product problem, you can see that x cubed times x cubed will give you x to the 6th. And then whatever these numbers are, when you distribute these and you combine the terms, you'll have 2x cubed terms that when you combined don't change the power. So sum and product actually works on this one too. So we're looking for two numbers that sum to negative 3 and have a product of negative 54. That will be negative 9 and positive 6. For this one, it looks like a sum and product problem, but before doing that, you can realize that they all share an x in common. So we factor out the x they share in common, and that leaves us with x squared minus 5x minus 6, x times x minus 6 times x plus 1. So it's GCF for this part, and then sum and product for this part. This one looks really awful. And it's confusing to think what you could do to start. So you might look for a common factor, and they share nothing in common. So common factor is out. But they are a difference of squares. So we're going to have the same structure as we had for this problem. We'll have 5 times 5 to give us 25, a to the 8th times itself to give us a to the 16th, because when you multiply, you add the exponents. 1 minus, 1 plus, so that they're conjugates. 6 and 6, b to the 7th, b to the 7th. So difference of squares works here as well. All right, so this is also coming from the factoring unit, but it also involves ideas from Unit 2. So Unit 2, we talked about roots, and there's definitely a root in this problem, but I think we'll need factoring to solve this one in the end. Let's see how it comes out. So first things first here, because we have the square root isolated, we're going to square both sides. So that will give us 4x minus 11, because the square and square root cancel out, equals 2 minus x times itself, because that's what squaring means. We get 4x minus 11 is equal to 4 minus 2x plus x squared. Now seeing this mix of x squared and x terms hints that we probably will need some tool like factoring or sum and product, which is a type of factoring, I guess, to solve this one. So I know that to solve a problem with factoring, we have to move all of our terms to the same side and have it equal to 0. So doing that, this will make our equation equal to 0. It gives us x squared. Negative 2x minus 2x minus 4x is negative 8x plus 15 equals 0. And now this is actually a sum and product problem. We're looking for two numbers that sum to negative 8 and have a product of 15. So x minus 5 and x minus 3 equals 0. This one, because it's equal to 0, the way you solve it is to make this factor 0, x must be 5. To make this factor 0, x must be 3. And if either factor is 0, then the product would be 0. Remember though, square roots are dangerous, and this is one of those cases where we do need to check our final answer for extraneous solutions. So to check it for extraneous solutions, we check them separately. Let's start with x equals 5. So to do this, we need to plug into the original problem. So I'm going to erase my scratch work there. So we have 4 times 5 minus 11. And we're wondering, is that equal to, so I'll put a question mark there, 2 minus 5. So this is negative 3, and this is the square root of 20 minus 11. This is the square root of 9. And we're wondering, does that equal negative 3? No, the square root of 9 is 3. And that is not the same thing as negative 3. So this is not a solution to the problem. Now we check x equals 3. So we get the square root of 4 times 3 minus 11 equals, and we're wondering if it actually does, 2 minus 3. This is negative 1. On this side we get 12 minus 11. We get the square root of 1, and we're wondering, is that equal to negative 1? But the square root of a number is a positive number, so we get 1 is equal to negative 1, which is not true as well. So both of our apparent solutions turn out to be extraneous solutions. So the solution set for this problem is the null set, the empty set, the set with nothing in it because there are no solutions. Now usually we would have put 5 or 3 inside of there, but because neither one of them is solutions, it has nothing in it. Next up, for problem 11. Okay, we've got some crazy stuff coming over from the problem above. Let's just erase that. If f of x is this and g of x is that, then for what value of x does f of x equal g of x? So we set them equal to each other. 3x cubed minus 7x squared minus 10x plus 18 equals negative 2x squared plus 2x minus 2. Now, because this is probably a factoring problem, seeing all of these powers of x, we can set it equal to 0 by moving these terms to the other side of the equation. So now we get it equal to 0, and now 3x cubed minus 5x squared minus 12x plus 20 equals 0. And we're stuck temporarily. It's not sum and product, it's not GCF, it's not difference of squares, but it is 4 terms here. So it's a factoring by grouping problem. So factoring by grouping is a descriptive name because you're going to split it into 2 groups right down the middle. So if you apply GCF to this group and this group separately, we should get our factors. So this group shares an x squared in common, leaving us with 3x minus 5 when you factor it out. And this group over here shares a negative 4 in common. Now you might say, well, how do you know it's negative 4? And one way you can think about it is, you know that you need to end up with the same group here and here. So, oops, it's pink still. So this would have been negative 4 times 3x would give you negative 12x, and then negative 4 times the same negative 5 that you have on the other factor would give you positive 20. So negative 4 looked like a good choice. Now this leaves us with x squared minus 4, the leftover piece, times the group they have in common, equaling 0. Now you might think you're done factoring now that you've done grouping, but it turns out that this one right here, this can be factored one more time using a difference of squares factoring. So you get x minus 2 times x plus 2. You still have your pink 3x minus 5 factor, and altogether they equal 0. So here we get x equals 2, here we get x equals negative 2, and this factor is a little bit more challenging, but remember, you're trying to figure out what does x have to be so that this factor equals 0. Well, solving for x after setting that factor equal to 0 shows you that x must be 5/3. So you get 1, 2, 3 solutions to this problem, which should agree with your intuition, because having a cube here means that you expect 3 solutions by using the fundamental theorem of algebra. All right, so I hope you guys found this video helpful. This problem was also from Unit 3. So it was designed to review the first couple of units from the semester, some stuff that we haven't talked about in a while that would be good to go back and review on your own if you're still finding challenging. So see you guys in class tomorrow.